Hey Algebra, and welcome to Simplifying Expressions with Exponents Part 2. Still looking at all of the skills that we have learned about exponents, skill 44, 45, 46, and 47. On the intro page to this assignment, there is like the notes page. Every single property of exponents that we have learned over the last couple of weeks is summarized right there. So I'm going to go ahead and start. I'm going to do every other problem. There's 2 of each type of problem. So let's start at question number 1 first of all. So I have some numbers. This whole thing is a multiplication problem. Those numbers, the 9 and the 8, they don't have exponents, so no exponent properties apply. It's just multiplying these numbers together. 9 times 8 is 72. And then I can't read the rest of the problem. And then I've got a to the power of 6 and a to the power of 3. Those are being multiplied together. In a multiplication problem involving bases, same base, but exponents, we don't multiply. We add the exponents together. So 6 plus 3 is 9, a to the power of 9. All right, so a couple of steps. X to the power of 6 on the top, x to the power of 4 on the bottom, parentheses, that whole thing is being raised to the power of 5. I'm going to do the stuff inside the parentheses first. And you actually could get away with not doing it first, but it's going to be a lot easier if we do. So inside the parentheses, I got x to the power of 6 in the numerator, x to the power of 4 in the denominator. It's a division problem, which means we subtract the exponents. 6 minus 4 gives us 2. There were, to begin with, more x's on the numerator. It's a bigger exponent of 6. So when I subtract the answer, x to the power of 2, that's going to stay as the numerator. The denominator is 1. I don't need to write that. Okay, so I did the division. I cleaned it up. Now it's just x to the power of 2 raised to the power of 5. So that's a base, x, to a power to another power. Multiply those 2 powers together. 2 times 5 is 10. Final answer. Next problem. Okay, I'm going to go ahead and rewrite this so we can read it better. So I got y to the power of 10 raised to the power of 5 over y to the power of 5. Since I have parentheses on the top and it's got multiple operations in the numerator, I'm going to do that first. So in the numerator, y to the power of 10 raised to the power of 5, that's a power to a power. Multiply those exponents. 10 times 5, 50. There's my numerator, y to the power of 50. And now, denominator of y to the power of 5. This is a division problem, same base in a division problem involving same base and exponents. Subtract these exponents. 50 is obviously the larger number, and that's in the numerator. So after I subtract 50 minus 5, I know that my answer is going to stay in the numerator because that's where the bigger answer was. 50 minus 5 is 45. Final answer, y to the power of 45. Okay, so let's write this down again. C to the power of 9 times c to the power of 6 in the numerator, c to the power of 7 and c to the power of 3 in the denominator. Got to go ahead and do the top first. So I need to multiply together the c to the power of 9 and c to the power of 6. It's a multiplication problem involving exponents, which means we don't multiply, we add them. 9 plus 6 is 15. Denominator, pretty similar. It's a multiplication problem, so we're going to add those exponents. 7 plus 3 is 10. Now I have a division problem, and in a division problem involving the same bases, subtract the exponents. Larger exponent is in the numerator, so after I subtract, my answer is going to stay in the numerator. 15 minus 10 is 5. Number 9. Negative 4 x to the power of 3 all over 5 inside this giant set of parentheses raised to the power of 0 I don't need to pay attention to anything inside the parentheses because anything to the power of 0 equals 1. And this whole entire problem is raised to the power of 0. Final answer, 1. Number 11. Z to the power of 9 divided by z to the power of 8. So division problem, my answer should contain only positive exponents. In a division problem with the same bases and they both have exponents, subtract. Larger exponent is in the numerator, so after I get done subtracting, I know my answer will stay in the numerator. If the denominator had the larger exponent, then I could subtract starting from the bottom number first, and my answer would live in the denominator, but that's not what happened this time. 9 minus 8 is 1. Z to the power of 1. I don't actually need to write that exponent. Z to the power of 1 means exactly the same thing as just z. Type the exponent if you want. You don't need it. Final answer. 13. So I got a bunch of different bases. R to the power of 8, G to the power of 9, Z to the power of 7, that's my numerator, R to the power of 6, G, Z to the power of 6 in the denominator. So we only get to deal with like bases. We don't get to combine R's with G's or Z's. They're not the same base. So I don't need to worry about multiplying across the numerator or multiplying across the denominator because those are not the same base. So similar bases. I've got an R to the 8 on the top and an R to the 6 on the bottom. That's division. Subtract the exponents. Larger exponent is in the numerator with the 8, so I'm going to subtract 8 minus 6, and I know that my final answer is going to stay in the numerator. G's, I'll do in green. The bottom one's got an invisible exponent of 1. That'll help us for subtraction purposes. 9 minus 1 is 8. It's going to stay on the top because I started with more G's in the numerator. I had 9 of them up there. Lastly, the Z's are going to do in blue, so still doing the same thing. We're subtracting exponents. 7 minus 6 is 1. You could write Z to the power of 1 if you want, but you don't actually need that 1. You could just put Z. And speaking of things we don't need, we don't actually need this fraction line because nothing was left in my denominator. All of the stuff in the denominator ended up canceling this time. Or if you wanted, you could delete that. Yikes. You could delete the exponent of 1. You don't need an exponent of 1. You can leave it if you want. You don't have to. Number 15. All right, simplify. No negative exponents. Use only positive exponents in your answer. Okay, so I've got an x to the power 6 in the numerator and just an x in the denominator. It's got an invisible exponent of 1. I think that'll be helpful. A couple of different ways you could proceed. First, you could say this is a division problem, and so I could subtract the exponents because division. Totally fine. Or, as an alternative, you could say, you know what? It's a negative exponent. Let's get rid of the negative exponent. Totally fine also. Let's do the one I just said. So we've got a negative exponent. Let's get rid of the negative exponent. It's in the numerator to begin with. Anytime you got a negative exponent, you're going to move that term to the other part of the fraction. So instead of the numerator, I'm going to move it down to the denominator. So I already had x to the power of 1 down there. Now I also have x to the power of 6 down there. I can't just leave the numerator empty. You have to actually put something there, otherwise it's not a fraction. So I'll fill that in with a 1. It's always a 1. If you end up with an empty spot, put a 1. And then in the denominator, I've got these two terms with the same base. I need to combine them. So this is multiplication. I'm going to add those two exponents together. 1 plus 6 gives me 7, and that stays in the denominator. 1 divided by x to the power of 7. Last problem. Here we go. Number 17. I got 24 x to the power of 9. The numerator, 4 x squared in the denominator. Simplify. No negative exponents allowed. These are numbers. They do not have any exponents. Don't do any of that fancy exponent stuff. It's just numbers. 24 divided by 4. You could think of it as a fraction. You could think of it as a division problem. In this case, since I know that 24 divides by 4 evenly, I'm just going to say it's a division problem. 24 divided by 4 is 6. If you get one that doesn't divide evenly, then just say it's a fraction. Reduce the fraction still. But mine came out evenly. So even if I say it's a fraction, it still reduces to 6. 6 over 1. I can just leave that as 6. These x's do have exponents. They both have the same base, x to the power 9 on the top, x to the power 2 on the bottom. That's a division problem. Subtract those exponents, 9 minus 2. There were more x's on the top that had the larger exponent, so my answer after I subtract is going to stay on the numerator. I don't actually have anything left in the denominator. I could put like over 1, but that's just extra writing. Still correct, means exactly the same thing, but why do the extra writing? 6 x to the power 7. And just to make sure the next one is the same. So that is all of the types of problems. Happy mathing!